Right, we're back again. So, now you know what CSV files really are. Let's talk about squirrels. This is an eastern grey squirrel. This is the particular kind of squirrel that we will be looking at data on. And the squirrels that the data was collected on were squirrels that live in the world-famous Central Park in New York. There it is. And the data was collected as part of the squirrel census, the Central Park squirrel census, the result of which was this huge map here, enormous map of Central Park and squirrel sightings. If you see there's a bit of a gap here in the middle, that is where the lake is. Obviously there's no squirrels in the lake. The squirrel census was carried out in October 2018. It was an attempt to collect data on every single squirrel in Central Park, and there's the website, www.thesquirrelcensus.com. The data are publicly available at this website, data.cityofnewyork.us. And I imported the dataset using Yannick Burr's Squirrel Tibble package. I then exported it in CSV format so that you can practice with it as a CSV, which is what we'll be doing later on. But first I'm going to show you a few things that you could do with it. Assuming you've already got it in CSV form, which you have because it's in the zip file that I've put onto Keats for this week. So, how to work with CSV files using readr, I should add. To import CSV data into R, always use the readr library. R can read CSV files without readr. It has built-in functions which look almost the same as the readr functions, but I would say don't use them, because then you will, if you do use them, you will run into the kind of problems that I was looking at in that practical demonstration of CSV files. readr exists in order to solve those problems, so you don't have to worry about whether your data is correctly quoted or not, or whether there are commas inside your character vectors, etc. Usually the function you will need to read CSV files into memory is read underline CSV, not read.csv. That is the built-in function, which is much older and it does less of the work for you, and it causes lots more headaches as a result because of the problems with CSV files that are largely solved by the tidyverse library readr and its read underline CSV function. Here's an example of using it. I'm using read CSV, and then the first argument is the path to the CSV file, which is in a directory called data. So we've got data / and then this file name, squirrels.csv. I'm using this little function here, col types equals cols, open bracket, close bracket, which tells readr to guess the type of data that's in each of those columns, so I don't have to tell it, assuming it can get it right, which it can, because I saved this data using readr as well. And then the resulting data frame, or tibble in fact, is assigned to the variable squirrel data. And then we see what squirrel data actually is. Squirrel data, I've piped that to the str function, which gives us the structure of a data frame. And as you see, we've got a column called X, which is numeric. We've got a column called Y, which is also numeric. Those are the coordinates of each squirrel sighting. We've got a unique squirrel ID, which is a character vector containing entries like this. It tells us which hectare we're looking at, which hectare of Central Park the squirrel was spotted in, whether this is in the morning or the afternoon, because the people that were counting squirrels took it in shifts, where they would either do morning or afternoon for looking for squirrels. We've got the date in this format, first the year, then the month, and then the day. And all of this. Oh yeah, combination. We've got the colours of the squirrel, the primary colour and secondary. So they might be grey and something else, black and something else. And then we have a number of columns. This doesn't all fit on the slide. We've got a number of columns which are logical vectors telling us what the squirrel is doing. Is it running? False, true, etc. Now, readr has actually been able to guess all of these classes, all of these vector types, which is one of the great things about readr. You don't have to tell it that this column is numeric, this column is character, this column is a date, this column is logical, etc. You don't have to tell it that. It is able to do that just by itself, by guessing. One of the reasons it's able to guess so well is that I actually created this CSV file in using the CSV writing function from readr, instead of using the built-in function, which might have caused more problems. So we can also save data to CSV format like this. I've got my squirrel data, and I'm piping that to write underline CSV, not write.csv, the built-in one. And I'm telling it the path, which is again data /squirrels2.csv, and that will save a CSV file, which is pretty much the same as the original. Okay. Again, I'm using the readr library, and this is the function you will pretty much always use. There is another function, but I don't think any of you are ever going to need it for anything, so we won't go into that. The point of using readr to write your CSV data is it makes it much easier for your collaborators to use the data. They won't then have to struggle with quotation marks inside the strings or any sort of problems like that. It's all handled for you by the function. And remember that your most important collaborator is your future self. So you're not just making this easier for other people who might work with you, because you might be working alone. You're making this easier for yourself in a few months' time when you try to go back to the data that you've already worked on and suddenly it doesn't work anymore. Well, hopefully it will work if you follow good practices such as using readr for both reading and writing CSVs. Okay. What about saving tables that you might have created to CSV format? No, you do that in exactly the same way. So if you've created a table of summary statistics for a data set using group by and summarize, you can then just save those as CSV files, load them into Excel, I'll show you doing this in a minute, and then copy and paste them into other Microsoft Office packages such as Word and PowerPoint. So here's an example of doing that. We've got our, what are we doing? We've got our squirrel data variable, which contains a data frame, or in fact a tibble with information about squirrels. We're then piping that to the filter function from dplyr. We're getting rid of any rows where the age is unknown. That's recorded with this question mark in that data set, or sometimes with NA. So both of those will get filtered out because we are telling it explicitly not to accept rows where age is a question mark. And then if you do any filtering on a column, then dplyr will automatically throw away the NAs. We pipe that to group by. We're telling it group by age. We pipe the grouped data to the summarize function. We're creating an n column using the n function, which just counts up how many rows there are in each group, and then we are creating a new column, %foraging, and that will be the mean of the foraging column. The foraging column is one of those logical vectors, true, false, true, false. Is the squirrel foraging? Is the squirrel looking for food? That means. So if you take the mean of a logical vector, what it will actually give you is the proportion between 0 and 1. It will give you the proportion of true values, because R treats, when you calculate the mean, it treats false as 0 and true as 1. So if you take the average of all of those zeros and ones, you get a proportion like 0.5, for example, if half of them are true. Multiply that by 100, you get a percentage. Round that and you throw away the decimal point, so you end up with a nice readable percentage with no decimal points. I've assigned that to the foraging squirrels variable, and if I just type that in, foraging squirrels, we get the tibble, the resulting tibble, this table of summary data. So you can see here we've got two possible ages, adult and juvenile. 2,568 adults, 330 juveniles. 50% of the times when adults were seen, they were foraging, that is, they were looking for food. 36% of the time that juveniles were seen, they were foraging. Okay. Right, well, what can we do with that? Up until now, all we've done with these tables of summary statistics is we have, we've maybe displayed them directly in the console in R, or we've assigned them to variables and then looked at them with view. How would you then put that into an essay, for example? Well, one of the ways that we can do that is by taking this table and then just saving it in a CSV. How do we do that? Well, we've got that summary statistics table is inside the foraging squirrels variable. We pipe that to the right CSV function, right underline CSV, I should say, because as I said before, you get problems if you use the built-in function right.csv. Tell it the path to save it to. I've put it inside a directory that I'm calling tables, so tables / foraging squirrels.csv, and that will give us a CSV file containing exactly what we saw on the previous screen. Okay, and I'm going to demonstrate that actually. Let's have a look right now. Let's have a look inside tables. Yes, this is where it's been saved. I've got a CSV file called foraging squirrels.csv. This has been recognized as openable in Excel, so if I double click, that's what we will get. Right, here we are. You see, there is the same table, but now it's been opened in Excel. So we've got an age column, an N column, percent foraging column, we've got adult and juvenile, the two values for age, the two grouping values for age, the numbers of them within, and the percentage of true values in the foraging column in the original data set. Okay, what can I do with that? Well, if I select all of that and I copy it, I could now, for example, create a PowerPoint slide. Let's create a new PowerPoint presentation. We'll put in a new slide. I'm going to tell it that I want this slide to contain a table. And we've got 3 columns and 3 rows. There we go. And now I can just paste the data that I copied. There we go. There it is. I've now got a PowerPoint slide with that table in it. And if I go to Word, I can do the same thing. Let's make a new Word document. And all I need to do now is just paste it directly. And there we are. We've got a table. And I could, I can include that directly into an essay, for example. There we go. We have it, a proper table, as you can see, with columns which we can adjust, like so, etc. And I can change the formatting if I want, make that look a bit nicer, etc. Great, there we are. So I can save that, of course. But let's take a little break.